The military and diplomatic engagements reveal that Russia and India are deep into advanced technical discussions regarding the Su-57. Russian aerospace officials have publicly stated that talks encompass licensed manufacturing at facilities currently producing the Su-30 MKI. This renewed push comes at a critical juncture for the Indian Air Force. The nation faces shrinking fighter squadrons, and the indigenous Advanced Medium Combat Aircraft program confronts pessimistic projections regarding its operational timeline. India desperately requires a capable fifth-generation platform to bridge the operational gap against rapidly modernizing regional adversaries. Moscow sees this vulnerability as a prime opportunity to integrate its aerospace industry into the Indian defense ecosystem for decades to come. The aircraft currently on the table is the Su-57E. The E designates an export variant. Historically, in the realm of global arms sales, export models invariably feature subtle but significant downgrades compared to the versions operated by the producing nation. These downgrades rarely affect raw physical performance. The Su-57E retains the formidable aerodynamics, supercruise capabilities, and massive payload capacity of its domestic counterpart. It can reach Mach 2.0 and sustain supersonic flight without afterburners while carrying long-range munitions internally to maintain a low radar profile. However, the compromises typically reside in the digital and electronic architecture. Export variants often feature restricted mission source codes, slightly detuned electronic warfare suites, and less sensitive radar modules. The primary goal of the producing nation is to protect its most classified technological secrets from falling into foreign hands or being compromised through reverse engineering by rival powers. Specifically, the Su-57E is powered by the interim AL-41F1 turbofans, each rated at 14,500 kg force in afterburner mode, delivering reliable supercruise at around Mach 1.3 and a combat radius exceeding 1,500 km on internal fuel. In contrast, the Russian Aerospace Forces frontline Su-57s are progressively receiving the second-stage Izdeliye-30 AL-51F1 engines, which provide up to 17,000 to 18,000 kilograms force, a 25% increase in dry thrust, 9% better specific fuel consumption, and significantly reduced infrared signature through advanced serrated nozzles and composite inlet guide vanes. This propulsion edge translates directly into superior sustained supercruise at Mach 1.8 to 2.0, extended loiter time in contested airspace, and lower detectability by infrared search and track systems, advantages that export customers do not automatically receive. On the weapons side, the domestic variant fully integrates the R-37M air-to-air missile with a 300 to 400 km range and the hypersonic Kinjal KH-47M2 derivative in internal bays, enabling first-look, first-kill engagements at extreme distances while preserving stealth. The Su-57E, however, typically operates with software-limited access to these munitions or requires customer-specific integration approvals, often restricting buyers to the R-77M and shorter range options unless additional clearances are negotiated. The electronic warfare suite tells a similar story. The domestic L-402 Himalayas system delivers full-spectrum adaptive jamming across L, S, and X bands, integrated with L-band AESA arrays for passive threat detection and real-time countermeasure libraries updated from operational data. Export versions feature a detuned variant with reduced power output, narrower frequency coverage, and preloaded threat libraries that exclude the most sensitive Russian intelligence, leaving the aircraft more vulnerable to advanced Western or Chinese electronic attack systems. The entire purpose of acquiring a foreign fifth-generation fighter is to secure absolute technological superiority over regional threats. A stopgap measure must provide undeniable tactical edge in highly contested airspace. If the Indian Air Force inducts an aircraft with restricted software autonomy and degraded sensor fusion, it sacrifices the very advantages that define modern aerial combat. Furthermore, the foundational stealth capabilities of the Su-57 family already spark intense debate among defense analysts. Experts widely assess the aircraft as having a larger radar cross-section than its Western counterparts, estimated at 0.1 to 1 square meter in the frontal aspect versus the F-35's sub 0.01 square meter, owing to its emphasis on super maneuverability over all aspect shaping. Coupling a questionable stealth profile with degraded avionics severely dilutes the combat effectiveness of the platform. A compromised Su-57E would leave Indian pilots vulnerable during complex beyond visual range engagements where absolute sensor superiority dictates survival. Supporters of the export deal argue that Russia is sweetening the offer by promising deep integration with Indian systems. Current proposals allegedly include the integration of indigenous technologies like the gallium nitride active electronically scanned array radar and domestic mission computers. This localized integration sounds appealing on paper, but it does not compensate for the underlying restrictions on the core aircraft architecture and advanced propulsion technology. The Su-57 program has struggled with engine development and currently relies on older AL-41F1 turbofans rather than fully matured next-generation power plants. Modifying an export variant to retrofit Product 30 class engines, unlock full EW libraries, or enable unrestricted hypersonic weapon bays is a complex engineering challenge that often leads to prolonged developmental delays and spiraling costs. India previously partnered with Russia on the fifth-generation fighter program but abandoned it in 2018 due to deep concerns over performance metrics and the refusal of Moscow to share critical source codes. Returning to the negotiating table to accept a similarly restricted export model would represent a strategic regression. Securing the domestic standard of the Su-57, or at minimum an Indian customized variant granted full source code access, would genuinely serve the long-term strategic purpose of India. An uncompromised platform would deliver the unmatched kinematic performance, advanced sensor fusion, and robust electronic warfare capabilities necessary to dominate the regional airspace. More importantly, complete access to the underlying technology would directly catalyze the domestic aerospace sector. Indian engineers could study the intricacies of stealth composites, internal weapons bay dynamics, and advanced thrust vectoring propulsion systems. This approach transforms a straightforward aircraft procurement into a massive technological leap for the entire nation. With Russia reportedly open to unprecedented source code transfer in the current talks, India possesses the leverage to demand exactly these terms. Anything less risks fielding a capable but ultimately compromised platform that falls short of the peer-level threats it must confront in the decades ahead.